Hey everybody, and welcome back to Algebra 2 Online. So the plan for today is to start using the unit circle to answer some questions related to kind of what the sine, cosine, and tangent of certain what we call reference angles are. But to start off, I just kind of want you to think about this problem. So remember, this SOHCAHTOA thing is only defined for right triangles like this. And based on kind of this picture, like the geometry, I want you to kind of think about what the largest value of sine and cosine could be, all right? And so if you think about it in terms of the picture, right, sine of this angle is opposite over hypotenuse, right? But by definition, the hypotenuse is the largest angle or largest length side in here. So sine of that theta is like the opposite over the hypotenuse, right? But we know that the opposite thing is less than or equal to the length of the hypotenuse side. And so this right here, right, should be a fraction that's going to be less than or equal to 1. And you could do the same idea for the cosine. You could do the cosine of that angle would also have to be less than or equal to 1, because you could have like a equilateral right triangle where you have like a 45, 90 in there, and in that case, this all these sides are equal. But based on this picture, you can kind of see that this hypotenuse is probably longer than this adjacent side here. So this is one where the cosine is going to be less than 1, but at most, the cosine can be 1, okay? And one of the things that we're going to see is actually if you graph sine, okay, sine just is this wave function that kind of keeps going like this. It truly is bounded above by 1, and it's actually also going to be bounded below by -1. And we're going to see actually today why that is. The same thing happens for sine. So this really is like the graph of y equals sine of x. And cosine, this is all stuff that's going to be coming up soon, but cosine kind of looks something like that. And this one is also bounded by 1 and -1, so you'll see that soon enough too. But you can totally see that just from looking at this picture of this triangle. So unit circle, probably one of the most important things that you study in Algebra 2, honestly. Really high school math, I would argue. And this slide in particular is a really important one because I'm going to make a connection between trig and this unit circle thing. So a unit circle is literally just a circle where the radius is 1, just like this picture shows, right? So you'd have like 1, 0 over here, 0, 1 there, -1, 0, and then 0, -1. And what I'm going to do is I'm going to actually just make a right triangle in here, all right? And what I want you to see, so I'm going to let that angle be theta, okay? The cosine of theta, right, is going to be equal to the x distance here, right? I'm just going to label that x over 1, or really just cosine of theta is equal to x, okay? If I do the sine of that angle, right, it's going to be equal to the opposite thing here, which is the y over 1, or just sine of theta equals y, right? And if I just kind of take this back a step, what we just showed is that in a unit circle, this is specific to a unit circle because it does need the hypotenuse to be 1, okay? In this special kind of circle, no matter what kind of right triangle I draw, as long as the right triangle makes its 90 degree with the x-axis, like any of these ones here, this point and this point and this point could always just be found by doing the x is the cosine of the angle and the y is the sine. What I mean by that is the angle is like, again, starting from this position and just rotating, in this case, to that spot. That point right there would be given by the sine and cosine of that angle, okay? It's kind of a neat connection between points on the edge of the circle and the angle that you rotate around, okay? If you think back to geometry, hopefully you know that the equation of a circle, well, actually in general, is something written sort of like this. It's kind of hard to see there. So the equation of a circle in general is written like that, and that's something that you're supposed to see in geometry, and that's one where the center is given by whatever that number 1 there is, comma number 2, and then the radius is, just the square root of r squared there. And if the center is at the origin, like it is here, okay, then the equation of this circle is truly just x squared plus y squared equals 1. That's the equation of really what we call the unit circle, okay? Now this is kind of a neat thing to see here. So we just saw that x was equal to cosine. So we get cosine squared theta, and that's actually how we write it. We put a little 2 there. It means the exact same thing as putting the square there, but we put this 2 right here just because we're lazy and we don't want to write parentheses. We also know that we just found out that y was equal to sine, so we can put a sine squared in there, and then equals 1, okay? This is true for any angles, which is crazy. If you take any angle you can think of, okay, you take the cosine of it, you square it, and you add that to the sine of that angle, and then you square it, it should always equal 1. That is kind of a crazy fact in math. And that's actually a really important thing to remember. It's something that will keep coming up later on in this unit. But cosine squared of an angle plus sine squared of the same exact angle is truly equal to 1. So, something to know. But a lot of important stuff here. So I want you to definitely know that, and I want you to know this. So there's a little acronym, okay, that I want you to also know, and it involves where trig functions are positive or negative, okay? So when we use a unit circle, what we're really using it for is to help us evaluate sine, cosine, or even tangent of an angle, a rotational angle, okay? And whenever you do this, you have to think of, again, a right triangle drawn where the base is, the 90 degree is formed with the x-axis, sorry. And if you just look at the triangles, it kind of tells you which trig functions should be positive, right? All of them, right, have, they're over, the hypotenuse is 1, right? So in every single one of these, you have a hypotenuse of 1, 1, 1. And so that part's always positive, and this negatives and only really come in based on the x's and y's, okay? So in these triangles, okay, like take this first triangle in quadrant 1 up here. This x distance is some positive number, right? Maybe it's like 0.8. This y distance is also a positive number. Maybe it's like, I don't know, a quarter or something. But anything you do with trig functions, like opposite over hypotenuse, adjacent over hypotenuse, or tangent, which is opposite over adjacent, any of those in that quadrant will be positive. So in the first quadrant, okay, these are your quadrants right here, all trig functions are positive. So that's kind of the nice one, right? In the second quadrant, though, there's going to be some negative things. So if you look at it, this distance right here is going to be a negative x, right? But this distance right here is a positive y, right? We go vertically up, that's positive y, but left, that's negative. And if you do cosine, right? Like take cosine of that angle right there, it's going to equal the negative number over 1, which is going to be less than 0. If you do tangent, right, it's going to be a positive number over a negative, which is less than 0. If you go through it, the only trig function that's positive is sine, because if you do sine of that angle, right, you can do opposite side, which is positive, over 1, okay? And so you get a positive number over 1, which is greater than 0. This is the only thing that's positive, only basic trig function that's positive in the second quadrant, okay? And again, I know it's kind of weird to think of the angle this way, but the angle is still coming from here. It's just, ending there. And so we can actually work with this triangle, okay? In the first quadrant, the angle is much more clear because it's literally just that little angle in there. But basically between 90 degrees all the way to 180 degrees, if you take, I guess I'll just kind of do this. If you take the sine of any of the angles in there, you're going to get a negative number. But if you take the cosine of them, positive, and if you take the tangent of them, it's also going to be positive, okay? Moving on to the next quadrant here. So notice this distance is negative, and this distance is negative. So in this case, right, the x and the y are both negative, and so if the x is cosine, the y is sine, then sine and cosine are both going to be negative in the third quadrant. But if you do tangent of an angle, right, again, the angle I'm talking about is that one here, always end on the hypotenuse. Tangent of that angle is a negative number, right, this negative number, divided by another negative number, which is greater than 0, double negative, right? So the only thing that's positive here is tangent. That's the only positive one there. And then last but not least, if you do the fourth quadrant, this distance, positive, right? But this distance, negative. And so if you do cosine of the angle there, then you get a positive over 1, which is greater than 0. So there's an acronym, and that's what you see here that I haven't talked about. And the acronym, there's a lot of them out there, but the one I always use is All Students Take Calc. And in this acronym, right, the A is short for all trig functions are positive. The S is short for only sine is positive. The T is that tangent is positive here. And the C is that cosine is the positive one here. So if you can remember All Students Take Calc, it kind of tells you which trig functions are positive where. All, sine, tangent, cosine. But where tangent's positive, sine's not going to be positive, in this kind of thing. So what we're building towards with all this stuff, you might wonder why we're doing any of this, is we need to be able to do problems like this really quickly, kind of in our head. Being able to find like the sine and cosine of like basic angles like this, okay? That is what we're building towards. And one of the things is just knowing like, so take cosine of negative pi over 4. We know that's down here in this fourth quadrant. And we now know that cosine of that is positive in that quadrant, right? So when I write down what this equals, right, it's going to have to be a positive number because cosine's positive in that quadrant. So that is an important thing, just to know where sine, cosine, tangent are positive or negative. Another thing that's really important is knowing the ratio of the sides in nice triangles like this, okay? So hopefully we kind of remember this because it's another thing from geometry that we should know. But based on a 45, 45, 90 triangle, you can figure out what the proportion of the sides can be if you just use Pythagorean theorem. So, using a squared plus b squared equals c squared, which is true for right triangles. Like one of the legs is x, another leg is x, right? And I just want to know what the hypotenuse is based on this kind of triangle, okay? And so I would get 2x squared equals c squared, sorry. And so if I square root, c should equal plus and minus square root of 2x, okay? But it's a length. It is a length. And so the negative makes no sense. So here, the hypotenuse should be square root of 2 times x, whatever the leg is, right? This gives you a proportion. So, if this is length 1, then the hypotenuse is length root 2. And that's true for any, scaled version of this triangle. Whatever x is, this is square root of 2 times x. Just to kind of show you how we can use this. So these are my proportions, okay? If the legs of a 45, 45, 90 triangle are 8, we can use that to figure out the hypotenuse. Because if this is 8, then this is just simply, right, 8 times the square root of 2. That's literally all it is, okay? This is like black, which is my bad. That should be 1 over square root of 2. If the legs of the triangle is 1 over square root of 2, then the hypotenuse, this is actually a really nice one, right? So now the legs are 1 over square root of 2, right? So I can go, over here, and I can just do 1 over square root of 2 times square root of 2, and this should be what my, hypotenuse is, and I can see it's 1. So that's kind of a really nice one. If you ever happen to have a triangle where the legs are 1 over square root of 2, this hypotenuse will end up being 1, all right? And then last but not least, if the hypotenuse is 12, what are the legs? Well, we know then 12 equals like x square root of 2, right? And we can just solve for x just by dividing by square root of 2. The legs would have to be 12 divided by square root of 2. That is what the legs of this kind of triangle would equal. But that is only true for the 45, 45, 90. And another common triangle that you definitely want to know is this one, the 30, 60, 90. Okay, I lost a dotted line there. And you can do a similar kind of thing where we can figure out the proportion. So my 30, 60, 90 is over here, right? And if you mirror it over, that's why I have this dotted right here. So basically I'm saying make that also an x right there. I basically get, an isosceles, or equilateral triangle, where you get 2x is the side length for every single side, right? Like you go x plus x is 2x, so this is 2x, this is 2x, and it's, because it's equal angle here, you're going to get equal length here and here. And so then you can figure out the other leg of this triangle just doing Pythagorean theorem again. So if you again use a squared plus b squared equals c squared, you can figure out what this needs to be. All right. So one of the legs is x. So I'm going to have x squared, and then I want to know what that last one is, okay? And I know my c is 2x, okay? So basically I'm just solving for that unknown, all right? And so this is, I'll just do it. This is 4x squared. 4x squared minus an x squared is 3x squared, right? And so the unknown leg is going to be plus and minus square root 3x. But once again, we are not concerned with the negative because it's a length. So that other leg, let me just maybe write that in here. The other leg would equal just square root of 3x. And so you get the proportion, again, you get a nice proportion where if you can figure out like the length of one of these things, you can get any of them because of how like the angles and sides relate in this nice triangle. So those proportions are really nice to know. And I kind of have them summarized over here. So in your 45, 45, 90, you got x, root 2x. In your 30, 60, 90, you've got x, root 3x. I just found that, right? And then 2x. And we can use this to do all sorts of evaluation problems without a calculator, which, just goes back to the idea that, like, I want to make sure that log base, 2 of 8 is 3, just like off the top of your head. That's like a nice log. And these are all nice sines, or these are both, I should say, nice sines and cosines. And so I want you to be able to do those off your top of your head. So the way these kind of problems work is basically you use a circle, like I've kind of got drawn here, a unit circle. 315, right, and this is only going to work if they're nice angles, of course, right? So 315, if you draw that, it's going to end in the fourth quadrant. And remember, always draw these triangles so that the 90 degree is with the x-axis. And if you do the math, right, if you add 45 to that, you're going to get 360. So this is nice problem because that's a 45 in there. That's like a nice triangle, right? If this is 45 and this is 90, then this is 45, okay? Now we know already, right, that my answer here should be negative, right? Because it's a sine, and we just talked about it over here, that the only thing positive in that quadrant is cosine. So it's going to be a negative answer. We just got to figure out what negative number it is. And that is where the triangle stuff comes in. So if you wanted to do sine of that, right, you would just do this over this. But we know, right, that the hypotenuse, the x over root 2 thing, is equal to 1, right? So if 1 equals x root 2, then this implies, right, that x would equal 1 over root 2. And so the x is the legs in the triangle. And so that is my answer, right? This thing equals negative because it's sine, not cosine or tangent or something, 1 over square root of 2. And when you do enough of these, you get to learn this kind of thing. You get to be able to do that like really, really fast. I could have just told you the answer in like a matter of like a second. But I had to kind of explain it, to teach it here. But the idea is just draw your reference angle, or draw your angle and get your reference angle, which is the 45 here. And then use the trig, or the geometry trig that we know from last year with your special triangles. Figure out what it is based on these triangles, and then you just figure out the positive, negative stuff based on the all students take calc thing, okay? So I'm going to go through another one. I'm going to do cosine, and I'm going to use the same graph, I think. So for cosine of negative pi over 3, negative pi over 3 is kind of roughly there, right? Negative pi over 3 is really negative 60, but I won't be saying those angles all the time. Just kind of in the beginning here, I'm going to kind of say it. Then actually I'm going to erase that. So that is my angle. That's my 90 degree drawn with the x-axis. And if this is negative pi over 3, right? That's really the same problem as cosine of negative 60, which means I'm in this triangle this time, right? Big surprise, 2 problems, 2 triangles. If this is a 60, right, this is a 30, this is a 90, I've got that triangle perfectly. I just need to use the proportions in this triangle, right? So here, we know that if 1, which is the hypotenuse, equals 2x, then x equals 1/2, right? So whatever I want to use over here, I'm going to just use x equals 1/2 to help me get the answer, okay? I want cosine, so I want adjacent, right, over hypotenuse, but I know that's 1. So I really just want that x distance right there. That is, kind of proportional to that thing right there. So literally, the x is the answer, right? So this whole thing would equal 1/2, and then you just have to do the kind of thing where you think, okay, is it positive or negative? And if you go back to the acronym, all students take calc. We know cosine is positive there, so we can go and just, square that, box that answer. Not a lot of work, but definitely some stuff you got to think about, and you get really fast at it. The idea is you can do these kind of off, off the head, just without any calculator or anything like that. So very, very useful for a lot of problems coming up too, to be able to do this really, really fast. So I have a bunch more here. I want to just kind of go through a few of them, and then I would recommend you try a few of the others, and I'll just write the answers kind of to the other ones. You can kind of check your work. So for sine of 0, 0 is literally right here. And this one seems kind of weird, but if you literally just go all the way back to this slide, sine is always the y value, cosine is the x. If you get one of these things where there's no triangle formed, right? So if you get 0 or 90 or 180, those kind of ones are on the axis, then you literally just look at these green numbers and you just take the x or y point, right? Sine is the y value. And so literally for that one, we just would write equals 0. It's just looking right there. That's all you got to do, okay? I want to do a tangent one because I haven't done tangent with you yet. So I'm going to do this one down here. So the first thing we're going to do is figure out our angle, or negative 4 pi over 3. The way I think about this is, this is negative 4 pi over 3 is like, negative 3 pi over 3 minus another pi over 3, right? And so if I go minus 3 pi over 3, that'd be at minus pi, right? And then I'm just going another pi over 3. So I'm in quadrant 2, right? So tangent is positive in the third quadrant, so it's going to be negative here. And then I just use my special triangle stuff. So this is like a 30, 60, 90 triangle. And we want to know the ratio between opposite and adjacent, right? And so if you just go to this picture, over here, you can see that this is actually exactly kind of the triangle we have. If you do this over this, you just get root 3 over 1, right? And so the answer is equal to root 3, and it's negative because tangent is not positive in that quadrant. So I'll put up the other ones just so you have the answers, but you should definitely check, make sure you understand how I got these answers. So that's what the other ones there would be. And you definitely want to make sure that you can understand where those all come from. This is basically what your homework will be. And that is kind of the basics of the unit circle.